Hey guys, we are today going over pages 226 through 229. We're going to look at the rest of the simple machines today. So we're going to be looking at pulley and wheel and axle, inclined plane, wedge and screw, and compound machines. All of these probably you're familiar with. You've used them before, I'm sure, in many different ways or capacities at some point in your life. So you might not have known that that's what they were, but as we read through this stuff today, you're gonna be like, oh, I've used that one before, or I've used that one before. So let's look at pulleys first. This is starting on page 226. You can follow along in your book, or you can just watch as I read the ebook here on the video. So a pulley is a grooved wheel with a chain or rope wrapped in the groove. Pulleys are used to raise and lower things. To pull something up, you pull down on the rope. If you want to lower something, you release the rope. Pulleys make work easier by changing the direction of the force or by reducing the amount of force needed to move an object. All right, so let's look at this fixed pulley. So in this situation, we see here, there's your wheel, here's your rope. These guys, these crazy pirate guys here, they are pulling down on the rope and the barrel is moving upward. Okay? So the direction of the force changed but not the amount of the force needed to lift the barrel. So let's read about a fixed pulley. A fixed pulley is attached to something, so it does not move. It makes work easier by changing the direction of the force, but does not reduce the amount of force needed to move the object. Flagpoles are fixed pulleys. So when they raise and lower the flagpole, it is on a fixed pulley similar to this one. All right, so let's look at the movable pulley. All right, so kind of in this way, it's almost kind of like the opposite of the fixed. It's kind of a flipped version. So the person, instead of pulling downward, is pulling upward, and it's just going like literally in the opposite direction. Other times it was kind of going over. This time it's going under. A movable pulley moves with the load or resistance. It produces a gain in force, but does not change the direction of the force. So see here, movable pulley moves up as force is applied. Produces a gain in force, making it easier to lift the barrel. All right, let's look at this next one, a block and tackle. So block and tackle combines multiple fixed and movable pulleys. The fixed pulleys change the direction of the force, while the movable pulleys reduce a gain in force. People use block and tackle pulleys to raise sails on sailboats. Big construction cranes often use a block and tackle to lift heavy pieces of equipment. Multiple mixed and movable pulleys combined provide greater mechanical advantage. Mechanical advantage is the decrease in effort that is needed to move an object. All right, so before we move on, this is the block and tackle. So as you can see, you've got both. You've got the fixed and the movable pulley here. So you're able to get more work done because you're using two. So that's where this mechanical advantage comes in. Again, mechanical advantage is the decrease in effort that is needed to move an object. These guys are going to have to do less work because they've got more mechanical advantage. All simple machines give some mechanical advantage. However, remember our definition of work. When you apply less force, you must apply it through a greater distance to get the same amount of work. Although a block and tackle requires less effort than a simple fixed pulley does, it takes a much longer piece of rope to lift a load. All right, let's look at wheel and axle. So here's an example of wheel and axle. We've got two here. We've got an actual wheel and an actual axle from a car or a truck. And then also right here, you're going to see the same thing in our screwdriver. A wheel and axle consists of a wheel and a rod or axle running through the wheel. Sometimes we apply force to the axle to make the wheel move a greater distance. This is how the wheels on a car work. At other times, people turn the wheel to make the smaller axle turn with greater force. Have you ever tried unscrewing a screw holding just the shaft rather than the handle of a screwdriver? You can get very little force and probably cannot move the screw very much. But when you turn the handle, the wheel, you get a greater force on the shaft, the axle. So this is your shaft, your axle, this is your wheel on that. Then think about a turbine. A turbine is another example of a wheel and axle. Water, wind, or steam turns the wheel that turns the axle. So we talked about that when we were talking about types of energy. So this turning rotates a magnet inside a coil of wire to generate electricity. A gear is a type of wheel and axle. A gear has tooth-like projections around the wheel. Some gears have teeth that interlock with the teeth on another gear. When one gear turns, it moves the other gears that it touches in the opposite direction. However, on a bicycle, the gears are connected with a chain. And both move the same direction. Gears are used in many mechanical devices. People use them in simple things such as can openers and also in things as complex as automobiles. So right here is another wheel and axle example. They were just talking about the bicycle gear. All right, so let's look at inclined planes. All right, so if you look at these situations here, this guy, he's going to do a lot of work lifting that box up a bunch of stairs or into this truck bed, okay? And then this guy has more of a slope, so it's going to require more of a force to get it done. But this guy, because the slope is longer, is going to require less of a force to push the box up into the thing. Even though the same weight of the box, they're all 30 kilograms, the force is going to be less, okay? It's going to be least difficult for him. And let's talk about why. So we have inclined plane. An inclined plane is a flat, slanted surface such as a ramp. This type of simple machine makes moving an object up a distance easier than lifting the object straight up. The mechanical advantage of an inclined plane is based on its slope and the length of the inclined plane. A more gradual slope requires less force to move the object, thus making the work easier. A more gradual slope, however, has a longer distance for the object to travel. So think about, if you ever had to push someone in a wheelchair, how hard it is to push someone up a hill at all, but especially a steep hill versus a more gradual hill, okay? It's going to be easier on a gradual hill than it would be on a steep hill. All right, wedge. So this is a wedge right here that's underneath the rock. All right, so let's look at what that is. So a wedge is two inclined planes. So an inclined plane, remember, is just like a ramp type thing. But it's two of them together, back to back, like this, like in a mirror image. Knife blades, axes, hatchets, and even the ends of nails are all wedges. A wedge splits or lifts objects. Long, thin wedges cut and split better than short, fat ones. This is why a sharpened blade works better than a dull blade. Friction keeps wedges in place. Without friction, a wedge would slide off the object that is trying to split or lift. Sometimes people pound wedges under objects to separate the objects from their surroundings. A wedge may be used to lift a heavy object just a little so that a lever can be used to move it further. So it goes under and lifts it just a little, and then you stick that lever like a crowbar up under it, and then you can move this rock. All right, so let's look at a screw. All right, so look at this. See, it's round and round and round, and it goes all the way around, all the way up to the top. Well, a screw is an inclined plane wound around a cylinder or cone. Okay, so you can see that this looks like a cone or cylinder. Like this part's more like a cylinder shape, but the base of it is cone shaped. Okay, so this is an inclined plane. As you know, as you can see, it gradually goes up as it goes from the bottom to the top of the screw, and then it goes down the other direction. Okay, so it's kind of like when you're driving on a windy mountain, around the mountain instead of straight up the mountain and straight down the mountain. Okay, that's kind of the same way. It's an inclined plane wound around the mountain so that it creates less work for your car. Instead of going straight up and straight down, that would be difficult for your vehicles. So, and especially in bad road conditions. So that's why they make roads a lot of times go winding around mountains a little better. So a screw is an inclined plane wound around a cylinder cone. The ridges in the screw are called threads. As these threads are turned, they cut into a material and hold the screw firmly in place. Pulling a screw out of a piece of wood without turning the screw is very difficult. Screws depend on friction to stay in place. Without friction, you could remove a screw easily, since it would not grip the material it was screwed into. You have probably seen screws holding together wood or metal pieces many times. Another example of a screw is the top of a jar. The lid has a screw and the two parts fit together to close the jar. Some winding mountain roads are also types of screws. Instead of going straight up a mountain, the road has a slight incline that goes around and around. It is easier to travel than a sharp incline, but it takes a lot longer. All right, so now we've learned about all the different types. So now let's look at what a compound machine is. A compound machine combines two or more simple machines to make work even easier. Scissors are an example of a compound machine. The blades are two levers working together, and the cutting edges are wedges. A screw and screwdriver working together make another compound machine. The screw itself is a simple machine, and the screwdriver is a wheel and axle. Most machines we use daily are made up of at least two simple machines. You can see that here on the scissors, all right? So what did we say that this was? These were the wedges, and these are the levers. The two blades are the levers, and the cutting edges are the wedges. I'm sorry, I said that wrong. Then you have your screw and your screwdriver, which is right here in this picture. All right, and we said that the screwdriver was your wheel and axle, and then your screw is a screw, incline plane wrapped around the cylinder or cone. All right, so that is the last of that lesson, and actually that is the end of this chapter as far as the reading goes. We will have some other activities that we're going to do with this chapter. We're not done with the chapter by any means, but that's the last of the reading pages. So let me know if you have any questions on any of the activities that I'm wanting you to do. You can post comments on the bottom of this video, or text or call or email me. Have a great rest of your day.